Hi guys, welcome to the first part of my YouTube series called Electrical Engineering Essentials for Technicians and Electricians. Hope you enjoy.
Hi guys, welcome back to Electrical Engineering Essentials. This is electrical engineering for people just entering the field. This is not what I'm going to be doing at a later stage, which is up until NQF level 8, but this is around NQF level 1 principles. So we'll start here. Let's go to the definition of what is electricity. Electricity is the flow of electric charge, typically through a conductor, such as a wire. It is a form of energy resulting from the movement of electrons, negatively charged particles, or other charged particles. Now, in this part of electrical engineering, we are going to be looking at electron flow through what they call the ocean of electrons, which is the conduction band of most metals. So for most part, you will find we will use metal to transmit these electrons from a higher potential to a lower potential. And in the case of AC current, back and forth. But yes, this is the principle of electricity. So if anyone asks you what is electricity, you can just say the flow of electric charge. Simple, that's it. Electrical engineering circles around a few laws, but I can't think of one more important than Ohm's law to understand. Ohm's law is V equals I times R, which basically means that your voltage is equal to your current times your resistance. These are parameters of electrical engineering that students have to understand. Basically, voltage can be expressed as pressure in a pipe. Current can be expressed as the amount of water flowing through the pipe, and resistance can be actual resistance to the flow of that water. So you could have high pressure on the one side with a lot of resistance and still have very little amps. This would basically be the analogy of pressure. Lots of people use the analogy of pressure. Anyway, these parameters are normally measured with a multimeter in the field. This is a Fluke 375FC, and on the Fluke itself, you can see the A and the omega sign, which is ohms, as well as the V. So typical multimeters will normally have these parameters. Now we will go through the alternating current and the direct current settings a bit later, but for most part, the alternating current setting is distinguished by what looks like half a wave, and the direct current is basically categorized by a straight or straight and dotted lines on the multimeters. So here you can see all of them. You can see the current, you can see the ohms, the ohm measurements, which is basically resistance, and then voltage, of course. Go to introduce another parameter called power. Now, power is measured in watts, and watts is basically the most simple equation for watts, in my opinion, is PV, which basically means that power is equivalent to current times the voltage, which is what we basically got to calculate straight after this. Now let's go and look at our most basic circuit over here. And the resistance. This is 1 ohm of resistance and 10 volts from the source. How much current will be flowing in your circuit? Now let's start. Okay, current is equal to V over R, which is still Ohm's law. This is all just mathematically V equals I times R, I equals V over R. It's all the same thing. So this will be equivalent to 10 divided by 1 is equivalent to 10. What is the unit? Amps. Yes. So if we clamped it with a multimeter on amps DC, we would have found 10 amps in this circuit. Anyway, so let's go on with it. The next unit I want you to calculate of the circuit is how much power will the circuit take. Power is in watts. The easiest equation, hope you remember it, PV. P equals I times V. P equals I, 10. Voltage equals 10, right? 100 watts. Circuit is 100 watts. So yeah, easy to calculate current and power from a simple circuit. I'll see you guys for the second lecture. We'll go a little bit deeper into the power series and parallel resistances, to just clarify how they work. We'll also just go into the basic parallel formula for resistances and capacitance in the next lecture.